Yeah. Okay. The Okay. Now we have the analysis toolpack. Click and random number generator. Random number generator. Here, how many column? One column. How many observation? How many random number? 20,000, right? 20,000. And a normal distribution. And then the average height is 162. 162. 162, for example, is the height is normally distributed with mean height. The average height 162. Standard deviation 3.5, all right? 3.5. And click, and you will obtain the 20,000 girl students' height. Here, all right? One decimal place, yep, right? Here. So what is the height of number one, student number one? The first height generated, hey, 161.98. What is the number of the second girl student's height? What is the number? 168. All the way we have 20,000 students' heights. Here, 20,000. Okay? And I'm going to visualize the distribution of the data, which is the purpose of the histogram and the frequency polygon. Understand? Okay. So go to the data analysis again. Here, data analysis here again. Histogram. Here, from, yeah, the first one, first cell, all the way to, whoa, first cell, yep, all the way up to 20,000, from A1 to A20,000, all right? Oh, I forgot the class limit. I needed to specify the class limit. Sorry, I need to specify the class limit first. I forgot to do it. Yep, here. Pull down all the way to 170. 173. I want it to be 175. Yep. What happened? Yep. 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 Here. Okay. And data analysis again. Here, A1 all the way up to 20,000. And the class limit You specify it, it plotted for you. Yeah, here. And if you wanted to see the ogive, it is also available. Yeah, that's the ogive. The frequency, the histogram, and the ogive. Hey, this is the ogive. All right, but we don't need it this time. I need this only this time. Yeah. I have to wipe it off because it is in Chinese. Because I'm afraid you will use this. You report to the administration with this that I use Chinese. I don't use Chinese, right? Yeah. And here, the frame. Yeah. And the color. This color. And here, that's the histogram, right? I think I have plotted this last week. And copy and paste here. Okay, suppose that we copy and paste here. Wipe it off. Wipe it off. All right. And no Chinese. Now the Chinese character is gone. Copy, paste. Yep. Because I can't use Chinese. And frequency, histogram. And frequency polygon. Hey, watch the color. Black is for frequency polygon, and red is the is for the histogram. Right? Histogram and frequency polygons. I think I gave you this plot last week, right? Remember? And oh, there is one more Chinese here. Class limit. Class limit. Yep. And hey, what if I take the histogram off from the plot, and we obtain, if you take it off, If you take it off, then we have frequency polygon only. Okay? We have frequency polygon only. Okay? So the bigger sample size, the closer is the histogram or frequency polygon. Yep. The bigger sample size, the better is the frequency polygon, the better the frequency polygon approximate the true distribution. Okay? The bigger sample size, the better the frequency polygon and histogram approximates the true distribution curve. Hey, which means that they are closer. The bigger sample size, the closer is the histogram and the true distribution. Or equivalently, hey, the bigger sample size, the closer are the histogram and the true distribution, or the frequency polygon and the true distribution. Okay, so that's the end of this chapter because I'm going to omit the next subsection. I'm going to omit here. That is where is my pen? Where is my pen? What happened? Where is my pen? Where is my pen? Hey? Here. That is. As the sample size increase, increases, the histogram and frequency polygon gets closer to the true distribution Hey, this is going to appear in your midterm exam. All right? It's going to appear in your midterm exam. And what I will ask, what happened to the histogram and frequency polygon as the sample size increase? Hey, I will ask you a question. What happened to the histogram and frequency polygon as the sample size increases? What is your answer? What is your answer? Your answer should be as the sample size increases, the histogram and the frequency polygon get closer to the true distribution. Hey, this is a fake distribution, and so is the histogram in the previous slide. They are both fake. Okay? They are fake distribution. But note that histogram and frequency polygon are both a fake distribution. But they are close to the true distribution true counterpart, which means true distribution. For large sample size. Okay, 10-minute break. See you in 10 minutes. Hello, hello. Roll call again. All right, 10 seconds. This time, 10 seconds. Okay, got it? I wish. Okay. Next chapter. Next chapter. I have to save this. 28th. Finance. Global finance, GF. Okay. Yep. And now, chapter chapter 3. Here. Please go to chapter 3. What is the what is the content of chapter 3? And the title is data description. And we have 4 sections. Number 1, measure of a central tendency, measure of variation, and you can also say measure of dispersion. All right, and a measure of position, and then exploratory data analysis, and then finally summary. All right. Okay. 3.1. Measure of a central tendency. Wow. No Chinese. Remember the please recall what we have learned last hour. What is this? What is this? This is the distribution of the TKU girl students' heights, right? The distribution of TKU girl students' heights. Hey, and from the figure we see that most of the girl students' heights gather around which number? 150 here, 150 here, No. 174 here? No. What do the girl students' heights gather around? Stands around. It stands the height stands around. Most of the girl students' heights are very close to. Most of them are gather around 162, which is the mean height. You see that? So 162. And how many girl students' heights are there in the column? How many? 20,000, which is too many. Too many to get any idea from this column. So, and we condense the data by the histogram. And how many bins? How many bins? I think there seems to be 30 bins. And this is called a bin, bin. 30 bins. And we use 30 bins to summarize the total total data set. Understand? So we use 30 to represent to 20,000. All right? And maybe it's crazy. Maybe the following question is crazy. Why crazy? You will see how crazy it is. Hi, listen. My question is, can we use just one number to represent the whole column data of 20,000 girl students' heights? Can we just use one number to represent all the data set? The answer is, you can say the answer is yes. You can just use one data to represent all the data set. If you wanted to, use just one value to represent all the 2,000 values, 20,000 values. Which one is the most representative? Which one will serve the best purpose, the purpose best? Which one? The lowest one? 150? I don't think so, because there are so few students here. And can we use 174? Can we use 174 to represent the whole column of data? Can we use it? No. So which one is the most representative? Some number in the middle, right? In a central location. Some number in the central location. In this example, hey, I think 162 is a good candidate. All right? Understand? Somewhere, the most, can we use, whoa. Oh, here is my crazy question. Hey, please don't use this to report to the administration that I use Chinese. Hey, don't. Yeah, crazy question. A crazy question. Can we use just one value, one number. To represent the whole data set. If yes, if the answer is yes, then which number is the most suitable? Which number is the most suitable? If the answer is yes, which number is the most suitable? Some number in the central location, right? The answer is some number in the central location. Answer. The most suitable number must be somewhere in the central location. Okay? Okay. Next page. What? Why? And we use this copy. Why? Why the one in the central location? As we can see, from the figure below, most of the data cluster around the central, the central location. Okay, so we need to some measure. We need to measures of central location. Or measure of central tendency. Right? Here. Most of the data cluster around the central location. So we need measures of central location or measures of central tendency. Next page. What happened? Eh? Oh. So measures of central tendency. Hey. You see that? I add an as to the measure. So it is measures of central tendency. So how many measures of central tendency here? We have, here we see 3 measure of a central tendency. 3. Okay. The first one is the mean. Okay. Or you can say average value. Average value. And then median. Median is the midmost value. Midmost. Okay. And the mode. And no Chinese. I have to wipe them off, or I will have my salary cut. I will have trouble. What happened to the? So how to calculate the average value? Let's go to the first measure. Go to the first measure. The first measure is the average value. Okay. Mean. What is the, how to calculate, how to obtain the mean of a data set? If a data set has values x1, x2, all the way all the way up to xn, then the mean value of the data is given by the sum of the n values divided by n. And the symbol here, x bar, is you read x bar, okay? I forgot ace. It reads x bar. And we have a shorter notation for this. The shorter notation, xi sigma I from 1 to n divided by n. That's the average value. Okay? Any question? Do you have any question? If you don't have any question, let's look at an example. If you see an example with no number, then it is my example. So there's no number. And if you see an example with number, then the number is from your textbook. Okay? So the first example is my example, my personal example. Hey, x1 equals 7, x2 equal 8, and x3 equal 9. Then x bar, okay, x1 plus x2 plus x3 divided by 3, which is 8, is the mean value of 7, 8, 9. Okay? An example 3.1. The number of confirmed avian flu cases for a 9-year period is as follows. Please calculate, please find the mean. What is avian flu? Avian flu is the virus comes from the something, the bird or chicken, something can some animal that can fly. That's avian flu, 禽流感. Okay, 9-year period. Okay, the first year there are 4 cases, 46 cases, 89 cases, 98 cases. Okay, and so on. And how to calculate? It's very simple. What happened? What happened to the yeah, here. And hey, the red spot here is the location of 46.2, which is the average value of the 9 numbers. All right. And is it the central location? Is it the central location of the 9 numbers? Approximately, yes. Roughly, yes. Is the central location. And the calculation of mean is simple. You just add them up, you just sum them up and divide it by the sample size 9. Okay, it's simple. Simple to calculate and conceptually simple. Okay, you can get the idea easily. Idea of central location easily. So, it's very popular. The mean is a very popular central measure of central location. Is a popular measure of central location. For its simplicity in calculation and its conceptual simplicity. Is a popular measure. Okay? And now it enjoy what? Eh? Oh, yep. Not this one. Yeah, this one. And besides, it enjoy many good properties, statistical properties, good good theoretical properties in statistics. It can be shown, but I'm not going to show it. I won't show it. I won't discuss it. Its properties. Okay? It's good properties. Okay? But what I'm going to address here, hey, it is address, not address. Address is where you live. Address means discuss. Is its drawback. What is the draw? What happened? What's wrong with the? But what is wrong with the? Then what is wrong with the with mean? Hey, keep in mind that mean does not go wrong every time. It goes wrong sometimes, just only sometime, maybe a few times. Okay, what is then what, and in what occasion the mean goes wrong? I think we don't, there are no 50 students here, but the attendance in the roll call is more than 60. I will do it manually this time. 黄书成啊，不，陈嘉诚，于庭珍，not here。蔡善林 ，you。吴若乐，not here。陈玉凯，简嘉佑，陈嘉莹哦，肖于琪，简维林，not here 哦，廖嘉瑜，蔡幸云，刘管亮，曾凯军，严敏仪，OK。肖雨辰，哦，严敏轩了 ，sorry。肖雨辰，林怡君，罗世凯，陈佩竹，林婉仪，钟尚哲，陈天磊，郭义和，谢玉新，陈友浩，邱子婷，郑方成，郑方成 not here， 戴方成 sorry， 戴方成 not here。林柏志，哎呀 I got it， 林柏志，吕伟彤，张寻柔，again， 周信宇，江怡琴，柯怡君，林玉轩，张顺宇，高嘉轩，邱爱文，陈仲威，林玉世，曾诗荣，蔡宜成，李佑强。It's so bad。王玉云，陈奕晨，林子琳，罗文玲，萧廷汉，朱子婷，罗伟俊，郭方轩，蔡坤伟，黄文凤， 李爱玲、郑伟志、朱汉生、郭凯福、Sophia、郭如意、王建玉、维特贝尔米、维特贝尔米 ，OK， 戴香雷、柯麦丽、杨尊好，施顺文 ，OK，Good，Got you，Gotcha。In MLB, gotcha means got you. So what's wrong with the min? Hey, let's go back to the example. Hey, using the Microsoft Excel. Hey, silence. Let's go back to the another the example here. Okay. Oh, not this one. This one. Yep. 4, 46, 98, 115, 88, 44, 73, 48, 62. So what is the average number? Hey, if you wanted to calculate the average number, just use average, equality sign here, average. From where to where? From D1, hey, this is the address, all the way to D9. That's 64.2, okay? And then I wanted to plot this. And then highlight and insert a plot here. This one, hey, no line. And oh, I forgot 64.2. 64.2. And 1 here. And then use this to draw a figure. No, not this one. This one. Yep. And which one is the 64.2? I think it must be this one. Which one? If I remove this cell, what happened? Oh, this one. This one, yeah, this one. I will make it bigger and different from the other. Yeah, this one. And different color. Eh? Where there's no color. Yeah, here. That's too big. Yeah, here. Yep, good. Yep. So I think it's the central location. No problem. You can say that, oh, it will represent because it stands at the central location. Yes, you can say that. But what's wrong? What in what occasion? Under what circumstances? Uh, the mean value goes wrong. What happened? What will happen? Hey, look at this. Look at this. Oh, no, 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 no. Yep, yep, I like it. Look at this. This is the mean, right? This is the mean. Hey, what if, hey, this one is 115. What is 115 increased to 215? What happened? Hey, hey, look at this. Look at this. 115 is now changed to 215. What happened? Hey, I will press the enter key and see what happened. The red dot goes to the right. And what happened if it is 300? This one is 300. Hey, hey, oh no, no, no. This one is AVERAGE. Yeah. Okay. Again. Let's make it back to 115. Yeah. This is the central location. And what happened if it is 200? Hey, the dot goes to the right. And what if it is 250? Goes further right. Goes further to the right. What if it is 300? It goes further to the right, okay? And what if it is 350? Further, right further, 400. 450. Okay? 500. You see that? What happened? Any volunteer? Any volunteer? Tell me what happened. Hey, in statistics, we call this extreme value. When the extreme value goes right, further and further right, then the dot will be driven to the right also. Understand? What happened? What happened? What just happened? Went right. Understand? Driven to the right. Why? Extreme value goes to the right, right? Further and further and further right. And then it is driven to the right. Okay? So as we can see from the figure, let's just make it 350. Copy and paste. Eh? Where is the red dot? Eh? What happened? Copy. When the extreme value 115 was changed to 350, then the average value or the mean is driven to the right further. Accordingly. Okay? So mean tends to be or is easily to be influenced by the extreme values. Okay? You should compare this to the previous figure. Okay? So that's for today. Another roll call. Hey, this time I will count the number of the previous roll call and compare with the following one. So don't pass again. Or otherwise, I will wipe them off. All the 3 roll call off, and your attendance is useless. You got no bonus. Don't piss me off. 不要惹毛我啊。I'm a little bit pissed off. That's the bonus. Hey, if you pass, I will wipe all the 3 roll call off. 10 seconds. Yes. Okay, later. Hey, wait, later. Huh? Yeah, I know. Wrong class. What? this time? Later. No, later. Oh, no, not this one. Okay. Yeah. I know. Wrong class. Another. That's for another class. This time this one. Yep. Yeah, I wipe it. I delete it. Yeah, yesterday I deleted. Any other problem?
那他说这一天就是那个他是错误的。
我弄掉了。哎。Which one? The previous one? Yeah. What?哎。什么名字？有啊。你是哪一个？你讲的是那个？嗯。Yeah. What? YouTube.
After that, I already make the YouTube to upload the video, but like I haven't got the video yet.
Oh, no. I didn't upload to the YouTube. I didn't.
No, I mean me to like upload to the right 对吗？就2个3个礼拜，老师问我 if I make a YouTube and I help you to do it.
Oh yeah. You can do it. Yeah.
But like I don't have the video. Like when will
Oh, you can download from MS Team. Download from here.
Oh, you recorded?
Yeah.